measurements in science. So this first graduated cylinder reads to the tenths place. The second graduated cylinder reads to the hundreds. So the second graduated cylinder, or a burette, has it's more precise. And you're going to see that more precision can mean a couple things, but precision overall has to do with being consistent. We'll get into that a little later. So why is there uncertainty? Measurements are performed with instruments, so no instrument can read to an infinite number of decimal places. So just like your car doesn't measure distance to an infinite number of decimal places. If you look at your car odometer, most odometers read to the tenths place. If you go buy gas, you're buying gas probably to a tenth or 100th of a gallon. So anytime you're measuring something, it has to have a level of uncertainty. The more decimal places that a measurement can read, the better it is. So if you look here, which of these balance has the greatest uncertainty in the measurement? And I kind of like to talk about it in terms of not the greatest uncertainty, but which one's more precise. It's this one here is on the right is more precise because it reads to the thousands place. It reads to 0.001. I can't tell on this scale if I bring it up, but I think it's only reading to 0.5. So the one on the right is more precise. So I'm going to skip past precision and accuracy, and I'm going to talk about Sig Fig. So you do not typically deal with Sig Figs when you are in math class. And the reason you don't do Sig Figs in math class is because you don't measure things. Your teacher gives you the numbers. So in science, we have to count Sig Figs because we have to be aware of the measurement. So there's rules. So rule number 1, this is it here. So I'd write this in your notebook. Rules for counting Sig Figs. Non-zero integers always count. So 3, 4, 5, and 6 are non-zero. So that means there's 4 significant figures in this number. So that's just the rule. Any non-zero numbers always count as significant figures. That's rule 1. Rule 2 has to do with zeros. So there's 2 types of zeros we're going to deal with. Actually, there's 3 types. The first type we're going to deal with is leading zeros. This is a leading zero. It acts as a placeholder. They do not count as significant figures. So in this number here, there are 3 significant digits because the 4, 8, and the 6 are non-zero numbers and they count. So for example, if you had a number that was 0.00511, there would only be 3 Sig Figs because the 2 zeros in the front don't count because they're leading zeros. If I had 0.00000035, there would only be 2 Sig Figs because the 6 zeros in front don't count. They're leading zeros. Now we have captive zeros. So I also call these sandwiched, which means they're in the middle. So this 0 here, it counts. It has to count because if you took it out, the number would mean something different. So there was 4 significant figures here. So if I had a number that was, 5,001, that's 4 Sig Figs. Another example are trailing zeros. So just like leading zeros, trailing zeros are placeholders. So these 2 zeros don't count. And you're like, well, how can a number like that not count? Well, actually, I should back up. This does count, are significant only if the number contains a decimal point. So I'm going to use this example down here and show you the difference. These 2 zeros count because they're followed by a decimal. So it's talking about that this instrument up here reads to the thousands place. So basically you're saying it reads a plus or minus 0.001. If you look at 9300, 9300 is a little different because 1, I can write it in scientific notation, times 10 to the third, and then these 2 zeros are placeholders. They're trailing zeros, so they don't count. So there's only 2 significant figures in this number. So if I have 5,000 as an example, that means there's only 1 sig fig there. I could write that in scientific notation as 5 times 10 to the third. That's just 1 sig fig. Now, if I have, 25.00 milliliters, these 2 zeros count because they're followed by a decimal. So I'd have 4 sig figs here. Exact measurements are called infinite number of sig figs. And you're like, well, what's an exact number? An exact number is what we call a conversion factor. So 1 inch is equal to 2.54 centimeters exactly. They have an infinite number of digits. They're exactly measured. If I have 12 inches is equal to 1 foot, that's an infinite. It's an exact measurement. 1 mile is equal to 5,280 feet. That is what we have infinite number of sig figs because it's an exact number. We know that exact measurement. So let's talk about this. How many significant figures are in each? Here's a practice, and it gives the answers on the side, but I'm going to explain why. How many significant figures are in the first one? Well, we know the 1 and the 7 count because they're non-zero numbers. The 2 zeros here count because they're sandwiched. And the 0 behind the 7 counts because it is to the right of the decimal. So there are 5 sig figs. On 17.10, we know the 1, the 7, and the 1 count because they're non-zero numbers. And the 0 counts because it's to the right of the decimal. On the third example, there are 5 significant figures because the 1 counts, the 8 and the 9 count because they're non-zero numbers. The 2 zeros in between are sandwiched. These 2 zeros here are sandwich zeros. They count. However, this 0 on the end here does not count because it is a trailing 0. This number is actually scientific notation, so this should be a 3 up there. So there's only 3 significant figures here because the 3, 2, and 9 are non-zero numbers, so they have to count. And this does not count here, this times 10 to the third, because that is talking about placeholders. The fifth example, there's only 2 sig figs because these 2 zeros don't count because those are leading zeros, and leading zeros do not count. And the last example, the 3 and the 2 are the only 2 that count because everything to the right, these are trailing zeros. Those are trailing zeros, so those don't count either. So let's talk about rules for adding, subtracting, multiplying, and dividing. So multiplication and division rules when we were trying to figure out sig figs is the same. So the number of sig figs in the result equals the number in the least precise measurement. So for example, if I put in my calculator 6.38 times 2.0, first I got to count sig figs in my problem. So I have 3 here on 6.38, and I have 2 here and 2.0. So when I round it, so your kids are always asking me, how do I know what to round to? Well, now you'll know because it's always based on sig figs. So if I put that in the calculator, I get 12.76. Well, my least number of significant digits is 2, so I have to round this number to 2 sig figs, and that's how I get 13. So for example, I'm not going to go through all of these, but I'm just going to show you some examples. So if you look over to the left, 3.24 has 3 sig figs. 7.0 has 2 sig figs. So that means my answer is going to be rounded to 2 sig figs. So that's how I get 23. Over here on the left again, I have 4 significant figures. I have 3 significant figures. When I divide them, my answer is going to be in the least amount, so I'm going to have 3 sig figs. So that means I'm going to keep the 4, the 2, and I'm going to round this up and make this a 2, and that's how I get 4.22. Looking at the third example, if you count your number of sig figs, these 2 zeros are what we call leading zeros. They don't count. So I have 1 sig fig in the first, and I have 4 significant figures in this number here. So that means I have to round my answer to 1 sig fig. So that means 0.0, those aren't significant, and then I'm going to have to round the 4 to the 5, so my answer will be 0.05. And then I'm not going to do the other 3 examples, but you can look at them and try to figure out how they got that answer. Let's talk about addition and subtraction for sig figs. Addition and subtraction is a little different because it's based on decimal place. So what I mean by that is I'm going to show you, I'm going to line them up. So if I have 6.8, let's pretend these are volumes, because these all should be measurements. They should all have units. And then I'm going to say 11.934. And I'm going to add these up. Well, when you try to figure out sig figs for addition and subtraction, it's that your answer is going to be rounded to the least precise measurement. So, for example, if I look at the decimal places and I allow them to line up, both numbers are in the tenths place. I have no numbers up here on the top measurement in the hundreds, or no here, or in the thousands. So I would have to round my sig figs to the tenths place. So when I add them, my answer is going to be 18.7 milliliters, because the least precise measurement is to the tenths, and that's what place they both have in common. So let's look over here at a problem, and I like to stack them because I think it gives students the idea of, when you're stacking them, what place do they have in common. So if I add these together, and you can add them in your calculator, but you can see they both have the tens place in common, so that's what you're going to round your answer to. So you're going to get a calculator answer like this, but you're going to round your answer to 3 sig figs, or to the tens place. Same for the second example. If I look here, I have the tens place and the tens place are both in common. The hundreds place I don't. So I'm going to round it to this place here, to the 2. So that's how I get 76.3. So if you look at the third example, now we're adding. So we have to be careful. So we have to look at the position. So this is to the hundreds and this is to the hundreds. So when I add them, this is what I get in my calculator, but I'm going to round my answer to this place here because that's what they both have in common. Same thing for for the fourth example, and this is the last one I'm going to do. This is to the tens place. They both are to the tens place. I don't have a hundreds or a thousands in common, so I'm going to round it to 709.2 liters. So take a minute, try to do the other 2 examples in here so you can figure out, maybe get an idea of how they got their answer. That's all for now. I will go back and talk about accuracy and precision here, but I want you to work on Sig Fig and practice in your homework. And if you look on the weekly agenda, it'll tell you what problems to do.